Stop for a moment, because one of the strangest truths about our lives is that everything we know depends on a star that will not last forever. The sun feels permanent. It rises over every civilization, every ocean, every forest, every mountain, every memory humans have ever made. It feels so stable, so reliable, so completely woven into the idea of life that it is almost hard to imagine it as a temporary thing. But the sun is temporary. It was born, it changed, it is changing now, and one day it will go out. Not suddenly, not as a supernova, not in some violent movie-style detonation that tears the solar system apart in a single instant. The real death of the sun is slower than that, and in some ways, more disturbing. Because the sun will not simply switch off, it will transform. And when it does, the entire inner solar system will be forced to transform with it. Before we go deeper, subscribe to Endless Astra for more real cosmic stories built on science, not fiction. To understand how the sun dies, you first have to understand why it is alive. Right now, the sun is a main sequence star. That means it spends its life doing the one thing stars like it do best: fusing hydrogen into helium in its core. That fusion releases the energy that has held the sun in balance for billions of years. Gravity pulls inward, fusion pressure pushes outward. The sun exists because those two forces have been locked in a long, stable argument. That balance is why the sun shines. That balance is why Earth has liquid water. That balance is why life happened here at all. But balance is not forever. The sun is not an infinite furnace. It is a machine running on fuel, and the deepest fact about its future is simple. One day, the hydrogen in the core will run low enough that the stable phase we call sunlight today will end. Not tomorrow, not in any human timescale. The sun is about 4.6 billion years old, and it still has billions of years left in its current phase. But stars are not measured against human history. They are measured against physics, mass, fuel, and time. And the sun is already halfway through its most stable life. When core hydrogen becomes depleted, the center of the sun will change first. The core will contract under gravity. That contraction will raise temperatures even more. And while the very center stops behaving like the sun we know today, hydrogen fusion will continue in a shell around the shrinking core. That is when the real transformation begins. Because as the inner core contracts, the outer layers of the sun will start to expand. The sun will grow and keep growing. It will become a red giant. This is the phase people often imagine most dramatically, and for good reason. The sun will not just become brighter, it will become vastly larger. Its outer atmosphere will swell outward into the inner solar system, and the quiet architecture of the planetary system we know will be broken. Mercury is almost certainly doomed. Venus is effectively doomed too. And Earth enters the most uncertain and most haunting part of the story. Some models suggest that the expanding sun may eventually engulf Earth. Others emphasize that the sun will also lose mass, which changes orbital distances and makes the final details more complicated. But that uncertainty should not comfort us, because Earth does not need to be swallowed to be destroyed. Long before the sun's outer layers physically reach Earth, the planet will become unlivable. The increasing luminosity of the aging sun will overwhelm the climate system. Oceans will evaporate. The atmosphere will change catastrophically. Surface conditions will become hostile beyond anything life as we know it could survive. The world will not need to fall into the sun to be finished by it. It may be sterilized first. That is what makes the sun's future so chilling. The star that made Earth possible will eventually make Earth impossible. And this is not some sudden betrayal, it is simply what stars do. As the sun expands into a red giant, its outer layers will become larger, cooler, and redder in appearance, even while the total energy output changes dramatically. The sky above any surviving outer worlds would no longer hold the sun we know. It would hold an enormous, swollen red star dominating space with a scale that would feel almost impossible compared with today's familiar solar disk. If humanity, or anything descended from it, still existed somewhere far from Earth at that time, the Sun would no longer look like the quiet anchor of life. It would look like a system-ending force. But even the red giant stage is not the final act. Deep inside, the Sun's core will continue changing. Once temperatures become high enough, helium fusion will ignite, producing carbon and oxygen. For a while, the Sun will find a new temporary balance. But unlike more massive stars, it does not have enough mass to keep climbing forever through heavier and heavier fusion stages. It will never become the kind of star that explodes as a supernova. It does not have the necessary mass for that ending. That detail matters because the Sun's death is not spectacular in the same way as the death of a massive star. It is quieter, more gradual, more like a stripping away. As the later stages unfold, the Sun will become unstable. Its outer layers will be shed into space. Those drifting shells of gas will expand outward and glow under the radiation from the hot, exposed core, creating what astronomers call a planetary nebula. The name is misleading. It has nothing to do with planets. It is simply a glowing shell of expelled stellar atmosphere, the remains of a star that could no longer hold itself together in the old way. For a brief cosmic moment, the Sun may become one of the most beautiful objects it has ever been. A ghostly, luminous cloud spreading through the darkness where the inner solar system once existed in recognizable form. A final display, a stellar ruin illuminated from within. And then, at the center of that expanding nebula, the Sun's true corpse will remain, a white dwarf. This is the remnant that so many people underestimate. A white dwarf is not a dim puff of leftover gas. It is an extremely dense stellar core, no longer powered by active fusion, containing a huge fraction of the Sun's mass compressed into a volume roughly comparable to Earth. Matter there is no longer behaving in the ordinary way it does in everyday life. The object is supported by quantum mechanical pressure, not by the fusion that once defined it. The Sun will not end as a fireball. It will end as a hot, dense ember, a white dwarf glowing with leftover heat. At first, it will be intensely hot, but without ongoing fusion, it will only cool, slowly, over spans of time far beyond human intuition. It will radiate away its remaining thermal energy and fade through unimaginable ages. If the universe lasts long enough, even white dwarfs cool toward darkness. That is the final emotional truth in the Sun's story. Our star begins as a great fusion engine, matures as the source of life, swells into a destroyer, sheds itself into a nebula, and ends as a dead stellar core cooling in silence. And that means the solar system we think of as stable is not stable in the deepest sense. It is a temporary arrangement built around a star in midlife. The orbits may look eternal from the perspective of a human lifetime, but they are not eternal. The warmth of daylight is not eternal. The climate that shaped every ocean and every living thing is not eternal. Even the source of the sky itself is a phase. That is why the Sun's death matters emotionally as much as scientifically, because it changes the way you look at everything lit by it. Every morning on Earth feels ordinary because the Sun has been there all our lives and all of human history. But in reality, we are living inside a stable window in the life of a star. Before this window, Earth was a different world. After this window, Earth will be gone or transformed beyond recognition. We live in the bright middle, and maybe that is the deepest lesson here. The universe does not preserve even its most life-giving structures forever. Stars evolve, worlds change. Stability is real, but temporary. The Sun feels permanent only because human lives are so short compared with stellar time. On the scale of stars, permanence is just duration. We have not lived long enough to watch end. One day, the sunlight on Earth will stop being the light of a main sequence sun. One day, the star that held every season, every harvest, every sunrise, every childhood, every memory of warmth will become something larger, stranger, and far more dangerous. And in the end, it will leave behind only a white dwarf, the dense stellar remnant of the star that once made oceans, weather, and life possible. The Sun will not explode like the stars that die young and heavy. It will fade through transformation. It will grow, strip itself, and collapse into a relic. And if there is anything haunting about that, it is this. The star we trust most is not the exception to cosmic change. It is one more example of it. Drop a comment. Which stage of the sun's future do you find most unsettling? The red giant phase? The destruction of Earth? The planetary nebula? Or the white dwarf that remains after everything familiar is gone?